What's going on, everybody? In the last video, I talked a little bit about complex numbers and where they come from and how to write them. So, complex numbers are typically in this form of a plus bi. And this a here is the real part of the number, so it's just a number that you're used to, like 1 or -5. And then this new part is called the imaginary part because we have this I in it. And the I represents the square root of -1. So today I want to talk about how we add, subtract, and multiply these numbers together. It's pretty simple, but let's go through a few examples here. So let's say that I have 7 plus 5i, and I want to add that to -4 plus 2i. So this is pretty similar to just adding polynomial terms together in the fact that we have to combine the like terms. So the real parts combine with the real parts and the imaginary parts combine with the imaginary parts. So what I'm going to do is make two groups. The real group, I have a 7 plus a -4. And then in the imaginary group, I have a 5i plus a 2i. And then you just combine like terms. So 7 plus -4 is 3, and 5i plus 2i gives me a 7i. And this is in the form that we want. So another example of this, let's say I had the square root of 2 over 2 minus the square root of 2 over 2i. And I want to subtract that with the square root of 2 over 2 plus the square root of 2 over 2i. So the same thing applies. We're going to make our real number group. So in the real number group, I have square root of 2 over 2 minus the square root of 2 over 2. And I have this plus sign here because at the end of the day, I want it in this form. And so in the imaginary group, I have negative square root of 2 over 2i minus another square root of 2 over 2i. So when I combine these together, this just gives me 0. And then this guy gives me a minus 2 times the square root of 2 over 2 times I. Then you can see that these 2's cancel, and I'm just left with minus the square root of 2 times I. So this is what we would call a purely imaginary number, since we don't have a real component here. Or this happens when a is equal to 0. Okay, let's do something different. Let's see what happens when I multiply 6i times 5 minus 2i. So this is similar to what we've been doing before, and you just use the distributive property. So real numbers can multiply with complex portions and vice versa. It's legal to do that. So what I'm going to do is distribute the 6i out to both the terms, and then I get a 30i minus a 12i squared. So this I squared is interesting because I'm basically saying square root of -1 times the square root of -1. And this is square root of -1 squared, which is just -1. So what I'm really saying is I have 30i minus 12 times -1. And when you work this out and you rearrange it, we get 12 plus 30i. And then let's do one more. Let's say that I have 1 plus 6i, and I want to multiply that by 5 minus 2i. So the way that you would do this is to FOIL it just like you would have if you just had real numbers. You would FOIL it the same way. So I have 1 times 5, that gives me a 5, and a minus 2i here. Then I have a plus 30i from the inside product, and then I have a minus 12i squared. So what this comes out to is 5, and if I combine the two imaginary components, I have a plus 28i here, and then I squared is negative 1, so I'll have minus 12 times negative 1. And then this is going to give me a 17 plus 28i. So I hope this video was helpful about how we can do some of the operations with complex numbers, adding and multiplying them together. The dividing operation's a little bit more involved, so I'm going to make a separate video on that. So stay tuned, and I'll see you for the next video.